This thing about life in the universe, you've done many TV series, and most recently one on the solar system.
Yeah.
Where the search for life is a main theme.
Well, yeah, we just saw, as we speak, last week, the Europa Clipper spacecraft was launched.
Yes.
On the way to Europa.
We have an entire show devoted just to that. We visited the Jet Propulsion Labs and
I saw
felt the excitement of everyone there.
It's great, isn't it? It's the first spacecraft I've seen, major spacecraft being built. So I saw the Clipper. And the thing is, the scale of that thing, it's the largest spacecraft, isn't it, that's ever been sent into the outer solar system.
If you add the...
the most massive, I think.
It may be, but there's another important fact. Solar panels have gotten more efficient. In the day, back if you were going to explore beyond the asteroid belt, you couldn't use solar panels because the intensity of the sun wasn't high enough. This one has a very deployable, large solar panel that'll help it along without having to rely entirely on the nuclear decay of plutonium.
Yeah, so it's a huge spacecraft.
Yes.
And the point is that Europa, Jupiter's moon, is a prime candidate for a habitable world. In the, what we know, almost certainly, I'm always, the people who I know who work on the mission say, don't say we know, we're almost sure there's a saltwater ocean below the surface. I think it's pretty indisputable now, so we're pretty sure it's there.
Yeah, but whatever is the skepticism, what would it be were it not a global ocean?
Yeah, it's very difficult to be because, and that's from many measurements.
Was it made of ammonia? I mean, there's not, water molecule is not rare.
Yeah. So it looks like salt water. Almost.
Yeah, and we have a lot of comparative planetology with, is it the Arctic, when it freezes over, you have these chunks of ice that will break and refreeze and readjust, and you can compare the images and you'd think you were looking at the frozen Arctic.
Yeah. So it looks, and there's more water in that ocean than all the oceans of the Earth combined, geologically active. There are questions about how the ice cracks and moves on the surface. So it's a fascinating mission. So that's Europa. Mars, of course, which you've probably spoken about many times on this podcast. Enceladus is another one, Saturn's moon. Even out to Pluto. I mean, even
Enceladus is the ones we see the plumes of geysers, I guess.
Yeah.
When at the right sun angle, you can see who took those pictures. That must have been Cassini. Right.
Yeah.
So,
and also there's some measurements from Cassini, the particles in those jets of water, which are consistent with hydrothermal vent activity on the floors. And hydrothermal vents are one of the plausible candidates for the origin of life on Earth.
Yes.
So you seem to have everything. The one thing I think Europa's got that arguably nowhere else has is it looks like that ocean has been there for many billions of years. That's the baseline scenario.
And we evolved life in less time than that here on Earth.
Yeah. I mean, it was present, 3.8 billion years ago?
3.8-ish, yeah.
And the Earth's 4.5 billion years old. So,
right.
Yeah, so it looks like you have a habitat that's been stable there. And I think that you can't claim that with anyone else.
In fact, it was taught that it took about 500 million years on Earth to get life going. But we were able to revise that number down because in the early Earth, these periods of heavy bombardment, it's not fair to start the clock while we're still getting slammed by, still accreting leftover rocks from the solar system as the temperature of the surface of the Earth is high enough to prevent complex molecules. Give us a chance, please. So the periods of bombardment subside, Earth's surface cools, now start the clock. And then it's about 100 million years.
Yeah. So
it's like that.
Which is one of the reasons I think if you speak to many biologists, they would say that might suggest that given the right conditions, then whatever the origin of life is, there's a reasonable probability given the right conditions because it happened quickly here.
Right.
So, but that's not definitive in any sense.
But it's certainly tempting to go there.
But then, but what I find very interesting then is though, when you ask, okay, but when did life get more complex than a single cell? You're then, I don't think there's any evidence in the fossil record back beyond about 600 million years ago.
It took a while.
Of anything.
Yeah, we languished as single-celled creatures.
3 billion years plus, but it seems.
So I think people who think about this problem are honest about that. And so in the search for life on other planets, we're really looking for single-celled organisms.
Well, it would be remarkable to see anything more complex. Well, it'd be remarkable to see a single cell because then you'd know. especially if it were biologically different. So you can really show that it's got a different origin. Because it's worth saying that on Mars, the material is exchanged between Earth and Mars. So it's not obvious that you couldn't.
And you make all these points in your series.
Yeah.
Right. So where can people find your series? It's streaming, I presume.
Yeah. We've got the new one is just on at the moment, actually.
That's what I'm saying.
So the solar system. So that will appear on Apple, I suppose, at some point, and other places. Yeah. Okay. I mean, at the moment, it's on the BBC. So and it's streaming on the BBC, and then it will head off around the world. One of the coolest things I think about Europa is that the habitat, the potential habitat, requires Jupiter because of the heating. It's liquid because of it's orbiting around a big planet. Mm-hmm. But it also seems to require, it requires the other moons, Io and Ganymede, to keep it in this orbital resonance, which keeps feeding the energy in from the gravitational field.
A family affair,
But it also might need the material from the volcanoes of Io on the surface of Europa, because they might provide what we call the oxidant, right? So life is. So
you're saying that an Io, which is badly stressed,
it's just one big volcano.
It's one big volcano. So it spews volcanic substance. Faster than escape velocity, apparently, and then which
lands on Europa,
and it goes into pathways that intersect other moons, Europa included.
Yeah,
and if you do this for 1 billion years,
and then the chemistry, and then it gets irradiated.
It helps out the chemistry.
Yeah, so one of the theories that I've spoken to people who are on the Clipper mission said is that that's part of the battery of life, that chemistry. So life, I can't remember who said it, but he said life. Someone said it's an electron looking for a place to land. That's what life is. So it's just in one way you can see life as electrons moving around. But that means you need the chemistry to is
that all we are? Just electrons looking for a place to land?
Well, that's what a description.
I'd rather be dust in the wind, whatever. All we are.
But I find that wonderful, because then you've got this habitat, which is a system. And as you said, comparative planetology you mentioned earlier, it's also true of Earth, isn't it? You can't understand Earth without understanding the system, the solar system. You need to understand the moon and how it stabilizes the spin axis, and you need to understand, of course, the sun and the way it interacts with Earth and so on.
I'm a few years your senior. I don't know if you would remember this, but I definitely do. The era where no one was thinking or caring about moons. In the solar system.
Yeah.
We have a dead moon orbiting us, oddly large, but fine. Let's go look at the planets.
Yeah.
And so every mission out to the planets, they looked over their shoulder and found moons which had way more geologic diversity than anything we're finding on the planet.
I found it interesting because
when you were in school, where were we
pre-Voyager? Voyager. So
see, I'm pre-Voyager, and Voyager turned the moons into worlds.
Yeah.
That's what happened.
Yeah. So the idea you have a habitable zone in a solar system, which is the zone within which, if you have a rocky planet orbiting and everything's right, and the atmosphere is right, you could have the conditions to support life on the surface.
Well,
liquid water
on
the surface, let's say.
Right.
And so.
But that turned out to be needlessly limiting.
Well, exactly. Yeah. So you just say, well, Mars, Earth, Venus in our solar system.
That's it.
But then you find habitable zones around gas giants. That, as you said, that was the great discovery of Voyager, I would say.
Yeah, it began with Voyager, really, for sure.
Yeah. It should be early 1980s, right?
So